10.2, example 7. In this example, we're going to go ahead and look at a particle moving along a certain path, and then we're going to find out velocity, acceleration, speed, the shape of the path, and which way it rotates. We have a particle that is moving an elliptical path so that its position at any time when t is greater than or equal to 0 is 4 sine of t, comma 2 cosine of t. So if we want to write that as a vector, it's going to be r of t is equal to 4 sine of t, comma 2 cosine of t. So the first thing I want to do is find the velocity and the acceleration vectors. So the velocity is just the derivative. So then it's going to be 4 cosine of t, negative 2 sine of t. And my acceleration vector is going to be negative 4 sine of t and negative 2 cosine of t. For the next part, I'm going to want to find the velocity, acceleration, and the speed at t equals pi over 4. So in order to find the velocity at pi over 4, all you have to do is plug it into the vector. So it becomes 4 cosine pi over 4, negative 2 sine pi over 4. And so we simplify that. So what this means, if our velocity vector is 2 radical 2 comma negative radical 2, our velocity is a vector that looks something like this. It has the x distance of 2 radical 2 and a y distance of negative radical 2. If I want to find the speed, this is the magnitude of the velocity vector at pi over 4. So then it's going to be the square root of 2 radical 2 squared plus negative radical 2 squared. So I get radical 8 plus 2, which is going to be radical 10. So the magnitude here would be radical 10. If I want to find the acceleration at pi over 4, all I have to do is plug pi over 4 into my acceleration vector, which was negative 4 sine pi over 4, negative 2 cosine pi over 4. So if I work that out, I'll end up getting negative 4 times root 2 over 2, and negative 2 times root 2 over 2. So my acceleration vector is simply just negative 2 radical 2, comma negative radical 2. So if I compare my velocity and my acceleration, my particle is slowing down in the x direction, and it's speeding up in the y direction because the signs are the same. For the next part, I want you to sketch the path of the particle and then show the velocity at the point 4 comma 0. So to do this, you're going to want to go ahead and graph the position on your calculator. And then after that, we'll have a sketch and we can find the velocity vector at 4 comma 0. So as this traces out, we can see that it's making a ellipse and it's rotating, it looks like clockwise. And so what you're going to want to do is go ahead and sketch that down in your notes. So now that we have it drawn in our notes, we want to draw the velocity vector at the point 4 comma 0. So I know the point 4 comma 0 is right here. And I want to draw the velocity vector that goes with it. So we have our position vector is given by 4 sine of t, comma 2 cosine of t. So the idea here is I need to find the t value that'll make this true at 4 comma 0. So then if I have the point 4 comma 0, this is my x and this is my y. So then I'm going to go 4 is equal to 4 sine of t And 0 is equal to 2 cosine of t. So then 1 is equal to sine, and 0 is equal to cosine. So here t is pi over 2, and here t is pi over 2 and 3 pi over 2. Because they both have a pi over 2, that's the t value that I'm going to use. So I have my velocity vector is 4 cosine of t, comma, negative 2 sine of t. So then I'm going to go ahead and plug in this pi over 2. So my velocity at pi over 2 is 4 cosine pi over 2, comma, negative 2 sine pi over 2. So that's going to give me 0, comma, negative 2. So that means my vector is pointing down 2. So I'm going to draw a vector that starts here and goes down 1, 2. And this is my velocity vector at pi over 2. And then the last question is, does the particle go clockwise or counterclockwise? Well, watching it trace out, we saw that it rotated this way, so it's going to rotate clockwise.